So we're just about ready to wrap up circles. And we're going to move on to a different shape. So we did triangles. Triangles lasted really long. Triangles was like 5 weeks long. Circles is only about 2 weeks. And then next week we're going to move on to our last set of shapes that deal with trig. So we're going to wrap up today solving equations using inverses in the unit circle. We're comfortable with this because the word solve is familiar to us. If I tell you to solve something, what does that mean I want you to do to x? Yeah, not just find it, but get it alone, right? We always want to get x alone. That's always the goal. So I'm going to give you a series of equations. It won't take us very many steps to do these. We want to work on getting x alone. So the directions would be solve for x. So part A would be this question. CSC x equals 2. So the directions are solve for x, which means get x alone, which means do something to both sides that would help me get x by itself. All right, what do I want to do? Apply on both sides so that I can have that x be by itself. The inverse. So x would be the inverse cosecant of 2. But what do I really mean when I'm asking you for the inverse cosecant of 2? What's connected to the inverse cosecant of 2? The inverse sine of what other number? 1/2. Okay, it's the reciprocal. The inverse sine of 1/2. When I'm asking you for the inverse cosecant, what you're really being asked for is the inverse sine of the reciprocal fraction 1/2, which is asking you for the y-coordinate position around the unit circle. So the answer has to have a pi on it, and what would be the appropriate pi? 1/6. You got it? And that's the final answer. So I think you'll feel comfortable with these because it's a little bit of algebra, getting x by itself, but then it's the unit circle as well. Okay, let's try another one. Okay, the tan of x is equal to -1. So to get x by itself there, what will I apply on both sides? Inverse tan. The inverse tan of -1. What do I really mean by that? What's the only way? I know how sine could be -1. I know how cosine could be -1. But what's the only way that tangent could ever be -1? It really is only when I have a negative and there's a rad 2 over 2 over another rad 2 over 2. That is the only way that I could ever have tangent be -1. So the answer to this is going to be a family that has pi on it, but what fraction family is this? It's the fourths, okay? Some kind of fourth. Now make sure you don't pick a fourth that causes you to go through quadrant 3 or into quadrant 3. So how do I say it to keep myself out of quadrant 3? 3/4, that would be an option, but there is a closer quadrant, a closer value. -1/4 is closer. If you picture it on the unit circle, those fourth positions, one in quadrant 2 and one in quadrant 4, those both are members of the fourth family, but in terms of which one is closer to 0, we certainly have one that is a shorter arrow, a shorter arc, and so we pick the shorter of the two. Okay, example C, solving for cotangent of x being equal to the square root of 3. So again, if we are using the idea of inverses, and we apply inverse to this, we want x to be the inverse cotangent on the square root of 3. But what do I really mean when I'm talking about the inverse cotangent? I'm talking about the inverse tangent of what different number? 1 over rad 3. And furthermore, what do I really mean when we're asking you about 1 over rad 3? 1/2 is the top number. Rad 3 over 2 is the bottom number. That's what really is going on here. And what that really means is tangent is sine over cosine. So sine over cosine is going to be the half on the top and the rad 3 over 2 on the bottom. So that is some pi family that belongs to what fraction group? What fraction group has that? The 6's. And what particular position has that combination of values? 1/6. Does this feel comfortable? Okay. All right, 2 more. So 2 cos x plus 1. 2 cos x plus 1. All right, let's work towards getting x by itself. We have a little bit more work to do. What should I do first? Subtract the 1. So taking away the 1 would give me -1 on the other side. Then what? Divide by 2. So cos x is -1/2. Now I can apply the inverse cosine. So x is the inverse cosine of -1/2. So I'm meaning that the x-coordinate on your unit circle is a value that's -1/2, and it can't be in or through quadrant 3. It is a third, okay, one of the third members, okay, and how much did you think it was? 2/3 is correct. Okay, 2/3 puts me in quadrant 2. -1/3 is closer. Let's check that out. So here's 2/3 pi. Here's -1/3. The problem with -1/3 is, what is its x-coordinate? It's +1/2 for an x-coordinate, and we want -1/2 for our x-coordinate. So it can't be, okay, that one is negative, but this one is the -1/2 rad 3 over 2. So we want the one that was negative. All right, last example, and we're done for the week. Okay, example E. Secant of x is rad 2. So to finish it up, we're going to use the inverse. So secant of x inverse of rad 2 over 2.
Staff and students, please excuse this quick interruption.
So what we really mean by that is 1 over the square root of 2. So we saw earlier, we were working on unrationalizing that is the equivalent of cosine inverse being rad 2 over 2. That was part of our working through the unrationalizing of what are equivalent radical fractions. So we're looking for the x-coordinate that assumes a value of rad 2 over 2. So we know in our terms of pi it has to be one of the 4th fractions, and this is going to happen in the first quadrant. So it's going to be 1 over 4 pi.